The atmosphere of October. There is something very special about the month of October. On Earth, specifically in the northern parts of the world, this is a time of transition. The air becomes crisp and cool. The leaves on the trees change their colours from deep greens to bright oranges, yellows and browns, before they finally fall to the ground. The days get shorter and the nights get longer. It is a season that feels a little bit mysterious. Culturally, we often associate this time with Halloween, a time for ghosts and stories of things we cannot quite see. It is fitting then that in the vast theatre of the night sky, a different kind of ghost story was taking place. While we were watching the leaves fall, astronomers were looking up, watching a traveller from the deep darkness approach our neighbourhood. The sky in October is often clear, offering a perfect window into the universe. But space does not share our seasons. It does not have autumn or spring. It has only silence, gravity, and the blinding light of stars. In this deep silence, a visitor named Comet Atlas was moving. It did not make a sound. In space, there is no air to carry the roar of movement. If you were floating right next to it, you would hear absolutely nothing. You would only see a massive cloud of gas and dust glowing with a soft, eerie green light drifting against the black background of the cosmos. The date of destiny, October 29th. For those who study the stars, the date of October 29th was marked on their calendars with great anticipation. This was not a random date. This was the day Comet Atlas was scheduled to reach its perihelion. Perihelion is a simple astronomical term that means the point in an object's orbit where it is closest to the Sun. Imagine a long, stretched-out loop. The comet travels along this loop. At one end, it is very far away in the freezing dark. At the other end, it swings tight around the fire of our Sun. October 29th was supposed to be that moment of the swing. Scientists and skywatchers hoped that on this date Atlas would put on a magnificent show. They hoped it would become bright enough to see with the naked eye, perhaps even rivaling the brightness of the planet Venus. They imagined a long bright tail stretching across the night sky, a celestial firework to celebrate the end of the year. But the universe is unpredictable. The event on October the 29th became something different. Instead of a grand display of light, we witnessed a silent tragedy. As Atlas raced toward that date, the heat and the gravity of the Sun became too intense. The comet did not roar in triumph. It crumbled. It was a moment of destruction that happened in total silence. The anticipation turned into a study of a broken object, a ghost that faded away just when we thought it would shine the brightest. The nature of the traveller. To understand why this happened, we must understand what Comet Atlas actually was. Its scientific name is C20YO, but Atlas gives it a personality. Atlas was not a solid rock like an asteroid. You should picture it more like a giant dirty snowball. It was made of frozen gases, water ice, carbon monoxide, and other chemicals mixed with dust and ancient rocks. This snowball was huge kilometers wide, but it was not very strong. For thousands of years, Atlas lived in the Oort cloud. This is a theoretical shell around our entire solar system incredibly far away. It is the freezer of the solar system. Out there, the Sun is just another bright star in the sky. It provides no warmth. In that deep freeze, Atlas was safe. It was solid and sleeping. But then something gave it a push. Perhaps a passing star nudged it, or the gravity of the galaxy shifted slightly. Atlas began a long, slow fall toward the Sun. As it fell, it picked up some speed. For centuries, it travelled through the empty space between the planets. It passed Neptune, it passed Jupiter, and it passed Mars. As it got closer to the Sun, the sleeping snowball woke up. The heat began to turn its ice directly into gas. This process created a beautiful atmosphere around the centre of the comet, which astronomers call a coma. This coma glowed with a cyanide green colour, making it look like an emerald floating in the dark. It was beautiful, but it was also the sign of the comet unravelling, a different kind of visitor. It is important to distinguish Atlas from other famous visitors we have seen recently, like Oumuamua or Borisov. A few years ago, an object named Oumuamua passed through our solar system. Oumuamua was strange. It was shaped like a long cigar or a pancake. It was dark and reddish. The most important thing about Oumuamua was that it was an interstellar object. This means it was not from our family. It was a tourist from another star system entirely. It came in fast, looked around and left just as quickly. It was like a car driving through a town without stopping. It was solid, hard and mysterious. Then came Borisov. Like Oumuamua, Borisov was also from another star system. It was the second interstellar visitor we ever detected. Comet Atlas, however, was different. Atlas was not a tourist. Atlas was family. It belonged to our solar system. It was a long-lost cousin returning home after thousands of years in the cold wilderness. The difference is crucial. Oumuamua was a hard rock that survived a journey between stars. Atlas was a fragile creature of our own making. It was a relic from the very beginning of our own solar system 4.5 billion years ago. It held the secrets of our own history inside its icy body. While Oumuamua was exciting because it was alien, Atlas was exciting because it was ancient. It was a time capsule. When we looked at Atlas, we were looking at the raw materials that built Earth preserved in a deep freeze since the dawn of time, the silent breakup. As the October date approached, the difference between a solid rock and a dirty snowball became clear. The sun is a powerful master. Its gravity pulls with immense force and its radiation burns with immense heat. Atlas was huge, but it was loosely held together. It was like a sandcastle. As long as it sits still, it looks solid. But if you try to move it too fast, or if the wind blows too hard, it starts to lose its shape. In the weeks leading up to October the 29th, telescopes began to see something worrying. The bright round head of the comet started to look elongated. Then it started to look fuzzy. Finally, high-resolution images revealed the truth: the heart of the comet had shattered. The dirty snowball had broken into 4 or 5 smaller pieces. There was no explosion. There was no sound, just a slow drifting separation. The pieces continued to travel together like a flock of birds, but the main body was gone. The bright hope of a spectacular naked-eye comet vanished with it. This creates a feeling of melancholy, a gentle sadness. We tend to think of space as a place of violent explosions and crashing asteroids, but often the events in the cosmos are quiet. A comet travels for thousands of years, covers billions of kilometers, only to simply evaporate when it finally reaches its destination. Atlas taught us that the solar system is not just a machine of clockwork planets. It is a dynamic, changing, and sometimes destructive environment. The silent approach of Atlas was a reminder of how fragile these ancient ice wanderers really are. It has slid into our view, whispered its secrets in a glow of green gas, and then crumbled into dust, leaving us to watch the empty space where a star almost was. Imagine the solar system not as a cold, empty void, but as a magnificent, dimly lit ballroom. In the center stands the sun, the grand choreographer, holding the entire room together with invisible strings of gravity. Every planet, every asteroid, and every speck of dust is a dancer on this floor, moving to a silent rhythm that has played for billions of years. To understand how the Parker Solar Probe survives and operates, we must first learn the steps of this celestial waltz. This is not a dance of random steps. This is a precise mathematical ballet governed by the laws of Sir Isaac Newton and Johannes Kepler, the high-speed swoop perihelion. In this ballroom, the dancers do not move in perfect circles. Instead, they move in stretched-out circles called ellipses. This means there is a time when the dancer is far away from the sun, moving slowly and gracefully, and a time when they rush in close for a dramatic, fiery dip. This point of closest approach is called the perihelion, shutterstock. Think of a figure skater spinning on ice. When her arms are stretched out, she spins slowly, but the moment she pulls her arms in tight against her body, she spins incredibly fast. The Parker Solar Probe does something similar. As gravity pulls it closer and closer to the sun, falling into the deep end of the solar system, it speeds up. At perihelion, the probe is not just floating, it is screaming through space at speeds that are hard to comprehend. We are talking about velocity reaching nearly 700,000 kilometers per hour. To visualize this, imagine flying from New York to Tokyo in under 1 minute. This extreme speed is nature's way of balancing the books. If the probe moved too slowly at perihelion, the sun's massive gravity would swallow it whole. The speed is its shield. The centrifugal force pushes outward just hard enough to keep it from crashing into the fire, allowing it to skim the surface before swinging back out into the cold dark. The concept of escape velocity. Now imagine you want to leave this ballroom entirely. You want to open the heavy doors and step out into the universe beyond. To do this, you need a specific amount of energy. This is what physicists call escape velocity. Picture a skateboarder at the bottom of a deep U-shaped concrete bowl. To get out of the bowl, the skater needs to pump their legs and gain enough speed to roll up the side and fly over the edge. If they are too slow, gravity wins and they roll back down to the bottom. On Earth, to leave our planet's grip, a rocket must reach about 11 kilometers per second. But the sun is much heavier. Its bowl is incredibly deep. To escape the sun's gravity from the orbit of Earth, you would need immense speed. However, the Parker Solar Probe has a stranger, more difficult goal. It does not want to escape. It wants to do the opposite. It wants to fall. You might think falling into the sun is easy, after all gravity is pulling you there, but it is actually one of the hardest things to do in spaceflight. This is because Earth is moving sideways very fast, about 30 kilometers per second, to avoid falling into the sun. If you launch a rocket from Earth, it keeps that sideways speed. It will just orbit the sun forever parallel to Earth. To get close to the sun, you have to cancel out that sideways speed. You have to hit the brakes. The magic of the Oberth effect. This brings us to the most magical maneuver in our ballet, the Oberth effect. Named after Hermann Oberth, one of the fathers of rocketry, this effect is like a secret cheat code of the universe. Imagine you are pushing a child on a swing. You want to make them go higher. When is the best time to push them? Do you push when they are hovering motionless at the very top of the arc num? You give them a shove right at the bottom, exactly when they are moving the fastest. Why? Because energy grows exponentially with speed. In the language of physics, kinetic energy, the energy of motion is related to the square of velocity. This means if you add a little bit of speed when you are already moving fast, you gain a massive amount of energy compared to adding that same speed when you are moving slowly. The fuel in a rocket engine is like the muscle in your arms pushing the swing. It has a fixed amount of potential energy. If you burn that fuel when the rocket is moving slowly at the top of the swing, it is inefficient. But if you burn that fuel when the rocket is zooming past a planet or the sun at top speed, the bottom of the swing, that same amount of fuel produces a much larger change in the shape of your orbit. For a spacecraft trying to go to Jupiter or Pluto, they use the Oberth effect to gain speed. They dive close to Earth or Jupiter, wait until they hit perihelion maximum speed, and then ignite their engines to accelerate. It catapults them into the dark with incredible efficiency. The reverse. Oberth maneuver. But Parker is unique. Parker wants to slow down. It wants to drop its orbit lower and lower, getting closer to the solar fire with every pass. To do this, it performs a reverse Oberth maneuver. Remember the car on the highway. To stop, you apply the brakes. In space, braking means firing your engines in the opposite direction of your travel. The logic of the swing set still applies, but in reverse. If you want to stop the swing, you don't grab it when it's high up in the air. You absorb the energy at the bottom when it's moving fast. When the Parker Solar Probe rushes toward the sun and reaches that screaming speed at perihelion, it is at its most vulnerable but also its most potent moment. By firing thrusters against its motion at this exact moment of higher speed, it sheds more orbital energy than it could at any other time. It seems counterintuitive to hit the brakes when you're going your fastest, but the math of the stars dictates that this is the only way. By stripping away this energy at the low point perihelion, the probe ensures that when it swings back out, it won't go as far as it did before. The high point of its orbit, aphelion, shrinks. The loop gets tighter. The dancer is pulled closer to the chest of the grand choreographer. It is a dangerous game. To slow down, Parker must dive into the very environment that wants to destroy it. It must endure the heat to shed the speed. It is a delicate balance of fire and mathematics, a waltz on the edge of a volcano, proving that sometimes to get where you want to go, you have to move with the rhythm of gravity, not against it. 33 billion tons. To the human mind, this number is almost impossible to truly grasp. It feels like a wall of text, just digits on a screen. But in the cold mathematics of spaceflight, weight is everything. Weight tells us what an object is made of. Weight tells us how hard it is to push. Weight tells us the history of a world. When our sensors first locked onto Atlas, the initial calculations came back with that staggering figure 33 billion tons. At first glance, this seems like a heavy object. To put it into perspective, imagine every single building in New York City, every skyscraper, every house, every bridge and every road crushed together into one ball. That massive pile of concrete and steel would still weigh less than Atlas. It is a mountain floating in the void. However, this is where the mystery begins to deepen, and where the fear began to creep into the control rooms on Earth. The impossible movement. The problem was not the weight itself. The problem was how Atlas was moving. In our solar system, objects usually behave in two ways. We have asteroids, which are essentially giant rocks. They are heavy, dense, and they tumble through space solely under the influence of gravity. They go exactly where the sun pulls them. Then we have comets. These are dirty snowballs made of ice and dust. When a comet gets close to the sun, the heat warms it up. The ice turns into gas, a process we call outgassing. This gas shoots out in jets, acting like a thruster on a rocket ship. This pushes the comet, changing its path and speeding it up. Atlas did neither, and yet it did both. As Atlas approached the sun, it began to accelerate. It was moving faster than gravity alone could explain. This is a classic sign of a comet. The scientists immediately looked for the tail. If it was speeding up, it must be shooting out gas. There should have been a massive glowing cloud of water vapor or carbon dioxide trailing behind it, but there was nothing. The telescope saw no tail. The sensors detected no water, no dust, and no gas. Atlas was a dry, dead rock. Yet it was accelerating as if it had an engine. No? This created a terrifying contradiction in the math. If it is a rock, it is too heavy, 33 billion tons, to be pushed by the tiny pressure of the sunlight. If it is a comet, it should be losing mass and showing a tail, but it is not. So how do you push a mountain without an engine? The hollow theory. There is only one solution that makes the math work. It is a solution that terrified some and excited others. The only way for the gentle pressure of sunlight to push an object that large is if the object is not solid. Atlas cannot be a solid rock. To match the movement, we saw the density of Atlas had to be impossibly low. It had to be lighter than water. It had to be lighter than styrofoam. This leads us to the hollow structure hypothesis. Imagine a steel ball bearing the kind you might find in a machine. It is heavy and solid. Now imagine a Christmas ornament of the exact same size. It looks solid from the outside, but it is just a thin shell of glass with air inside. The Christmas ornament is incredibly light. You can blow on it and it will move. We believe Atlas is the Christmas ornament. For Atlas to weigh 33 billion tons and yet move so easily, it must be a shell. The calculations suggest that the outer wall of this object is perhaps only a few millimeters thick. Think about that. An object the size of a city traveling between the stars for millions of years, protected by a skin thinner than the walls of your house. If this hypothesis is true, Atlas is not a planetoid. It is a construction. Nature does not build hollow spheres. Nature builds solid clumps. Only intelligence builds empty spaces. Interstellar engineering. If Atlas is hollow, we must ask, what is it? The most popular theory among the optimistic scientists is that Atlas is a solar sail. Humans have experimented with this technology. The idea is to build a giant shiny sheet like the sail of a boat and let the light of the sun push it. But human solar sails are flimsy sheets of plastic and foil. Atlas appears to be a tank version of a solar sail. It is likely a rigid protective shell. Perhaps the sail part is the shape itself. If you flatten a sphere, you get a disk. If Atlas is a wide flat disk or a long hollow tube, it catches more sunlight. Let us compare this to human engineering to visualize the scale. Imagine the largest oil tanker ship on Earth. It is a massive steel beast mostly hollow inside to hold the oil. Now imagine that ship is 10 kilometers long. Now imagine you strip away all the engines, the crew quarters and the heavy machinery, leaving just the outer steel hull. That is Atlas, but the material must be stronger than anything we possess. To survive the impacts of micrometeoroids, tiny space rocks that hit like bullets for millions of years, this skin must be incredibly resilient. It suggests a form of interstellar metallurgy. Maybe the 33 billion tons is not rock, but a composite metal grown in zero gravity. A metal that heals itself when hit, a metal that does not rust or degrade. The echo in the dark. The concept of a hollow object brings a haunting question. What is inside? If you build a house, you put people in it. If you build a tank, you put fuel in it. If you build a computer, you put data in it. Is Atlas a fuel tank for a larger mothership that was lost long ago? Is it a derelict probe, a hollowed-out asteroid used to hide sensors? Or is it a generation ship? In science fiction, a generation ship is a vessel designed to travel for thousands of years. Since the trip takes so long, the people who start the journey will die before they arrive. Their children and their children's children will live their entire lives inside the ship. If Atlas is a hollow tube rotation would create artificial gravity on the inside walls, imagine a landscape wrapped around the interior of a cylinder. Rivers that flow in a circle. Fields of crops that look up at the ceiling, which is actually the ground of the other side. With 33 billion tons of mass, you could line the interior with soil, water and atmosphere. You could hide an entire civilization inside that rock, shielding them from the deadly radiation of open space. The weight of silence. However, we must remember the silence. We heard no radio signals, we saw no lights. If Atlas is a ship, it is a ghost ship. The weight of 33 billion tons is heavy, but the weight of the mystery is heavier. We are looking at an object that behaves like a ghost. It has the mass of a mountain, but moves like a feather in the wind. It looks like a rock, but has the density of a cloud. It forces us to accept one of two things. Nature is stranger than we know. There is a natural process completely unknown to human science that can create a hollow ultralight rock that accelerates by itself. We are not alone. Someone built this. Someone mined 33 billion tons of material, melted it down and forged a shell to sail across the dark ocean of the universe. As Atlas spins away from us, returning to the dark, it keeps its secret. The 33 billion tons drift silently, a monument to a civilization we may never meet, or a quirk of physics we may never understand. It is a silent giant passing through our village in the night, leaving us to wonder what passed us by. The observation deck was bathed in the soft, cold hum of the spectrometers. To the naked eye, the object hanging in the void was a silent, jagged rock tumbling through the darkness like a lost mountain. But to the sensors, it was screaming. The team was not looking at photographs. They were looking at ghosts, chemical ghosts trapped in light. This was the art of spectroscopy, the detective work of astronomy. By splitting the light reflecting off the object into a rainbow of colours, the team could read the dark bands in that spectrum like a barcode at a supermarket. Every element in the universe has a unique fingerprint, and right now the object was trying to confuse them. At first glance, the chemical profile was disappointingly normal. It looked exactly like every other dirty snowball that had drifted in from the Oort cloud. The dominant signal was the signature green glow, a beautiful but toxic halo that surrounds most comets. This was caused by two specific chemicals reacting to the sunlight: diatomic carbon and cyanogen. Cyanogen is a close relative of cyanide. On Earth, it is a deadly poison, the stuff of spy novels and tragic endings. In space, however, it is simply a common molecule that fluoresces with a brilliant ghostly emerald light when hit by ultraviolet radiation from the sun. For days, this green fog was all they could see. It was a dazzling light show, a perfect distraction. Dr. Aris, the lead chemist, tapped his screen in frustration. He compared the green glow to a magician waving a colourful handkerchief to hide what his other hand is doing. The comet was presenting a face of ordinary chaotic nature. It was saying, "Look at me, I am just a ball of gas and ice." But the team dug deeper. They began to analyse the crust hidden beneath that green fog. The outer layer appeared to be frozen carbon dioxide, dry ice mixed with ancient dust. This supported the deep time camouflage hypothesis. The theory was elegant in its simplicity. If a machine travels through the galaxy for millions of years, it does not stay clean. It moves through nebulae, dust clouds, and asteroid belts. Over eons, gravity does its work. Dust settles on the hull. Ice crystals freeze onto the metal. Slowly, layer by layer, a synthetic object becomes encased in a shell of natural debris. It builds its own disguise. The object looked like a comet because it was wearing a comet like a winter coat. The turning point came at 04 hours ship time. The object was approaching the frost line, the distance from the sun where heat begins to truly vaporize frozen gases. In a natural comet, this process is gradual. As the sun gets closer, the ice warms up, turns to gas, and the tail grows larger. It is a smooth curve on a graph, a gentle awakening. This object did not wake up gently. The alarms on the mass spectrometer did not whine. They chirped once, a sharp notification of an impossible value. The ratio of isotopes, the different heavy and light versions of atoms, suddenly shifted. In nature, the ratio of carbon-12 to carbon-13 is fairly constant. It tells you where the comet was born, but in a matter of seconds the readings from the object flipped. The natural dust shell cracked open not from heat, but from pressure from within. A jet of gas erupted from the dark side of the object, the side facing away from the sun. This was the first clue. Natural jets usually happen on the sunny side where the heat is. A jet on the dark side suggested a controlled release of valve opening rather than ice melting. Dr. Aris watched the chemical breakdown of that jet with widening eyes. The spectrometer was no longer detecting the chaotic mix of dirty ice. The confusing noise of the mask was gone. Instead, the sensors picked up a sudden pure spike of refined helium and trace amounts of metallic vapor, specifically titanium and vanadium. These elements do not simply float out of a melting snowball in pure forms. Helium is often used as a coolant or a pressurizing agent in fuel tanks. Titanium is the skin of aerospace engineering. The green cyanide cloud was pushed away by this new invisible exhaust. It was as if the object had exhaled. The narrative of the data changed instantly. The dirty snowball model collapsed. Nature is messy, it mixes things together. Nature gives you mud. This new reading was too clean. It was industrial. The sudden shift in chemical composition acted like a signal flare. It suggested that deep beneath the crust of millions of years of accumulated space dust, a system had detected the proximity of the sun. It had felt the heat, checked its internal clocks, and decided it was time to wake up. The chemical masquerade was falling apart. The dry ice and the cyanide glow were just the wrapping paper, and that paper was now tearing. The outgassing was not sublimation. It was a venting sequence. The sudden drop in internal pressure suggested pumps cycling on. The spike in noble gases suggested a reactor coming online. Dr. Aris looked at the readout, his face pale in the blue light of the monitor. He realized they were no longer studying geology. They were watching an engine start. The comet had stopped drifting and had begun to breathe. The chemistry had stopped telling a story of ancient ice and started telling a story of waking machinery. The green glow was fading and something much darker and much more precise was revealing itself underneath. When we look at the universe, we usually accept that things happen randomly. Rocks float in space, stars burn, and sometimes gravity pulls things together. But there is a limit to how much we can blame on luck. There comes a specific moment in any investigation where the coincidences pile up so high that luck is no longer a sufficient explanation. With Oumuamua, we have passed that limit. When we look at the numbers, the orbital path, and the specific way this object moved through our neighbourhood, the idea that this was just a random space rock becomes statistically impossible. Let us look at the path Oumuamua took. In our solar system, the planets Earth, Mars, Jupiter, and the others orbit the Sun on a mostly flat disk. Imagine a dinner plate floating in space. The Sun is in the middle, and the planets are peas rolling around the rim. Astronomers call this the ecliptic plane. Because of how our solar system formed, almost everything natural that we see, asteroids, comets, and dust, stays somewhat close to this flat dinner plate. It is the flow of traffic in our neighbourhood. Oumuamua did not follow the traffic laws. It did not come from the side like a normal visitor. It came from above. It approached our system from the north almost perfectly perpendicular to the flat disk of our planets. It dived down towards the Sun at a steep angle, cut through the plane, and then shot back out. This unique angle is important because it means Oumuamua avoided the gravitational bumps and pulls of the planets for most of its journey. It had a clean direct line to the centre of our system. If you were trying to shoot an arrow into a crowded room and wanted to hit the bullseye without hitting the people, you would shoot from above, not from the side. That is exactly what Oumuamua did, but the angle is only the beginning of the story. The real mystery lies in the specific encounters it had with the planets. Space is incredibly empty. The distance between planets is vast. For an object to enter from outside the solar system and pass close to one planet is rare. For it to interact with the orbital distances of multiple planets is extraordinary. As Oumuamua dived in, it passed the orbit of Mars, then it crossed the orbit of Earth. It passed us at a distance that, astronomically speaking, is a stone's throw away. It then swung around the Sun and passed the orbit of Venus. Finally, on its way out, it passed the orbit of Jupiter. It threaded the needle between the major players of our solar system with shocking precision. It did not just wander through the empty darkness at the edge of the system, it came right into the living room where the planets live. Astronomers have crunched the numbers on this. They looked at the speed of the object, its starting position in the galaxy, its rotation, and its strange cigar-like shape. When they combined all these factors, they tried to calculate the probability of a natural rock doing this by accident. The result is staggering. The statistical probability of a random natural object having this specific combination of shape, orbit, and lack of heat emission is estimated to be roughly 1 in 200 million. Let's pause to think about that number, 1 in 200 million. To understand how unlikely this is, we have to stop thinking in abstract numbers and start thinking in real-world terms. Imagine you are holding a 6-sided die, the kind you use to play board games. If you roll it, you have a 1 in 6 chance of getting a 6. If you roll it twice, the odds get harder. Now imagine you're in a casino. You watch a man walk up to the craps table. He picks up the dice and rolls a perfect 6. Then he does it again and again. He rolls a 6 10 times in a row. The people in the casino would stop watching the game and start watching the man. If he rolled a 6 20 times in a row, the security guards would come over. Why? Because at a certain point, luck is mathematically impossible. If someone rolls that many 6s, you do not assume he's the luckiest man alive. You assume the dice are loaded. You assume the game is fixed. You assume there is an intent behind the result. Oumuamua is the cosmic equivalent of rolling a 6 20 times in a row. First, it was the shape extremely long and thin, unlike anything else. That was the first roll of the dice. Then it was the shine, it was 10 times more reflective than a standard comet. That was the second roll. Then it was the speed, it was sitting still in the galactic waiting room before we hit it. That was the third roll. Then came the non-gravitational acceleration, it pushed itself away from the Sun without a tail. And finally, this perfect, precise dive through the ecliptic plane, missing the planets but coming close enough to scan them. Each one of these factors is rare on its own. But when you stack them on top of each other, the natural explanation collapses under the weight of the math. To believe this was a rock, you have to believe that nature just happened to sculpt the weirdest rock ever seen, threw it at the weirdest angle possible, and aimed it perfectly at the habitable zone of our star all by accident. There is a principle in science called Occam's razor. It suggests that usually the simplest explanation is the right one. Skeptics use this to say, it's just a rock that is the simple answer. But is it? Is it simple to invent 5 or 6 different new theories to explain one object? We have to invent a new type of hydrogen iceberg, a new type of dust bunny, and a new type of collision history just to make the data fit the rock theory. However, there is another explanation that fits all the data perfectly without needing to invent new physics. If this were a probe sent by an intelligent civilization, none of this is a coincidence. If it were a probe, the shape is designed to minimize friction or maximize scanning area. If it were a probe, the shiny surface is a heat shield. If it were a probe, the path from the north was chosen to avoid gravity wells until it reached the target. If it were a probe, the meetings with Earth and Mars were not accidents, they were the mission. When we look at the probability of 1 in 200 million, we are left with a choice. We can believe that we won the cosmic lottery and saw a rock that defies all statistical models, or we can accept the possibility that the dice are loaded. This object knew where it was going. It moved with purpose. It behaved exactly like a ship navigating a star system would behave. When we remove the impossible, whatever remains, however improbable, must be the truth. And the truth suggests that Oumuamua was not a random visitor. It was a targeted event. The universe is vast and chaotic, but it is rarely this precise, and this level of precision implies a navigator. The date was October the 3rd. In the vast silent theatre of our solar system, a drama was unfolding that would change our understanding of the cosmos, yet it happened without a sound. For months, astronomers on Earth had been watching a traveller from the frozen depths of the Oort cloud. It was Comet Siding Spring, a mountain of ice and rock moving with terrifying speed. But as it approached the red planet, the narrative shifted from a simple astronomical flyby to something far more tense and calculated. This was not just 2 objects passing in the dark, it felt like a deliberate meeting, a rendezvous arranged by gravity and orbital mechanics. On this specific day, the distance between the comet and Mars began to close dramatically. To the naked eye standing on the Martian surface, the comet would have looked like a fuzzy, brilliant star growing brighter by the hour, threatening to outshine the Martian moons. The atmosphere was thick with anticipation, not just in the control rooms of NASA, but in the silent, dusty expanse of space itself. The comet was moving at roughly 56 kilometers per second relative to Mars. At that speed, a collision would have been catastrophic, changing the face of the planet forever. But the comet did not hit. Instead, it executed a perfect grazing path skimming the upper atmosphere of Mars in a move that looked less like an accident and more like a pilot threading a needle. This brings us to the eyes we had watching the event. Orbiting Mars was the Mars Reconnaissance Orbiter, a spacecraft equipped with the most powerful camera ever sent to another planet, HiRISE. This camera is a marvel of human engineering, capable of spotting a dinner table on the surface of Mars from hundreds of kilometers up. But photographing a comet zipping by at hyperspeed is a completely different challenge. It is like trying to take a clear photo of a bullet while riding on a roller coaster. The team at the Jet Propulsion Laboratory had to program the spacecraft to turn and track the comet with extreme precision. They were pushing the hardware to its absolute limit. The goal was to capture the nucleus of the comet, the solid heart hidden inside the cloud of gas and dust. As the moment of closest approach neared the camera, shutter clicked. The images that came back were grainy and pixelated, but they were historic. They revealed that the nucleus was smaller than expected, perhaps only a few kilometers wide, yet it was spinning and active. However, what the camera didn't see was just as important as what it did. The sheer proximity allowed for a unique opportunity, one that leads to the fascinating hypothesis about the true nature of this encounter. Imagine for a moment that the comet was not just a rock but a carrier. In the realm of spaceflight, if you want to drop a probe onto a planet without using massive amounts of fuel to slow down, you use an atmosphere to brake, or you perform a flyby to release a lander. This is where the October 3rd event becomes a subject of intense speculation. The trajectory of Siding Spring brought it so close to Mars that it passed well within the orbit of the outer satellites. The hypothesis suggests that this close shave was the perfect moment to deploy smaller probes. If an intelligent observer or an automated alien system wanted to place sensors on Mars, this was the ideal delivery system. The comet acts as the mothership. As it whips around the planet, utilizing the gravity of Mars to alter its course, it could silently release a cluster of small, hard-to-detect probes. These probes would not need heavy engines. They would simply detach, caught by the gravity of Mars, and spiral down to the surface or settle into a stable orbit. Because the comet is surrounded by a massive coma, a cloud of dust, gas and ice particles spanning thousands of kilometers, this cloud acts as a perfect camouflage. A few small metallic objects dropping from the main body of the comet would be invisible to our cameras, lost in the noise of the dust storm. It is the ultimate stealth insertion. While Earth scientists were busy analysing the chemical composition of the gas, the comet could have dropped off a payload of sensors, leaving them behind as it sped back out into the darkness of the solar system. But why Mars? Why would this planet be such an important target for reconnaissance? To understand this, we must look at the solar system strategically. Mars is the ultimate outpost. It is close enough to Earth to monitor us, but far enough away to remain hidden. It is a stable platform with a solid surface, unlike the gas giants Jupiter or Saturn. It has a thin atmosphere that allows for clear viewing of the stars and of the blue planet next door. If you were an outside observer mapping this solar system, Mars is exactly where you would set up camp. It is the high ground of the inner solar system. Furthermore, Mars itself holds deep secrets. We know it once had vast oceans, thick air, and potentially life. By dropping probes here, an observer isn't just watching Earth, they are archiving the history of a dead world. Mars is a museum of planetary evolution preserved by the cold and the vacuum. The encounter on that day in October was a fleeting moment where two histories crossed paths. The chaotic frozen history of the comet, born at the dawn of the solar system, met the rusty weathered history of Mars. Whether it was just a cosmic coincidence or a functional deployment of alien technology remains a mystery buried in the red sands. But as the comet faded into the blackness leaving Mars behind, one could not help but feel that the red planet was no longer as empty as it was the day before. The encounter was over, but the observation had perhaps just begun. To understand the true genius of the Atlas trajectory, one must first understand the concept of a solar conjunction. In the simplest terms, this is a phenomenon that occurs when a planet or other object in the solar system passes directly behind the Sun from the perspective of Earth. It is a common occurrence in astronomy, a regular part of the clockwork of the heavens. However, in the case of Comet Atlas, this was not merely a celestial event, it was the ultimate camouflage. For weeks leading up to late October, astronomers tracked the comet as it raced inward from the dark frozen edges of the solar system. But as it approached its final destination, something critical happened. The angle between the comet and the Sun began to close. In tactical terms, Atlas was entering the glare. This is the Great Blind Spot. The date of October the 29th was not random. It was perfectly timed to coincide with the moment of maximum obscurity. On this day, the geometry of the engagement formed a nearly perfect straight line. Imagine a line drawn from the center of the Earth passing through the center of the Sun and continuing straight to the comet. This alignment meant that for all intents and purposes, Atlas ceased to exist for observers on Earth. The tactical advantage of this position cannot be overstated. The Sun is a chaotic, roaring ball of nuclear fire. It emits radiation across the entire electromagnetic spectrum from radio waves to X-rays. When an object passes close to the Sun in the sky within just a few degrees of the solar disk, it is drowned out by this overwhelming noise. It is like trying to spot a firefly hovering next to a lighthouse beam while standing miles away. The signal of the comet, its reflected light and heat, was utterly lost in the background static of the star. This is where the technological limitations of Earth became painfully apparent. Humanity has built the most advanced eyes in history to watch the universe. We have the Hubble Space Telescope, the James Webb Space Telescope, and massive arrays of radio dishes on the ground. Yet in the face of the Sun, these machines are helpless. Take the James Webb Space Telescope, the crown jewel of modern astronomy. It is designed to see the faint heat signatures of the oldest galaxies in the universe. Because it is so sensitive, it must always keep its back to the Sun. If it were to turn and look toward the inner solar system, its delicate sensors would be instantly destroyed, burned out by the intensity of the solar light. It simply cannot look at the danger zone. Similarly, optical telescopes on the ground are rendered useless. You cannot observe the stars during the day because the Earth's atmosphere scatters sunlight, turning the sky blue and washing out everything else. Even the specialized solar observatories, which are designed to look at the Sun, face a challenge. They use an instrument called a coronagraph, which places a small black disk over the Sun to block the direct light, allowing them to see the Sun's outer atmosphere. However, the glare is still so intense that there is a zone of exclusion around the sun where nothing can be seen. Atlas slipped exactly into this zone. Therefore, on October 29th, the world went blind. There is a profound psychological tension in this blindness. For the scientists and strategists tracking the object, the data stream simply stopped. One day the telemetry was there, numbers, updating positions plotted, and the next there was nothing. It is a feeling similar to a submarine captain watching a torpedo on sonar, only to have it vanish into the noise of a thermal layer. You know it is still there, you know it is moving fast, you know it is getting closer, but you cannot see it and you cannot measure it. During this period of the conjunction, the comet was moving at its maximum velocity. As objects get closer to the sun, gravity pulls them harder, acting like a slingshot. Atlas was accelerating to speeds of hundreds of thousands of kilometers per hour. Yet to the human eye it was invisible. It was performing its most aggressive maneuver while completely hidden under the cloak of the sun. This creates a unique tactical nightmare, the uncertainty window. When you lose track of an object in space, your prediction of where it will be in the future becomes less accurate with every passing hour. Small forces like the pressure of sunlight pushing on the comet or the gravitational tug of Mercury can slightly alter the path. Without visual confirmation, these tiny errors compound. By the time the object emerges from behind the sun, it could be thousands of kilometers away from where you expected it to be. The silence during these days was heavy. The only thing humanity could do was wait. It was a waiting game played in the dark, despite the fact that the enemy was hiding in the light. The trajectory suggested that Atlas was not just using the sun for gravity assistance. It was using the sun as a shield. It approached from the day side, masking its final approach in the one place where our defenses could not look. If one were to design a trajectory specifically to defeat Earth's detection capabilities, it would look exactly like this. A natural rock does not care about blind spots. A natural rock does not time its perihelion, its closest approach to the sun to perfectly align with a solar conjunction relative to Earth. Random chance can explain many things in the universe, but the precision of this alignment felt less like nature and more like a calculation. So as the world turned and the days ticked by, the feeling was not one of scientific curiosity but of dread. We knew that when Atlas finally emerged from the Great Blind Spot, it would be coming out on the other side with tremendous speed, likely on a new vector, and we would have very little time to react. The sun had given it the ultimate cover, allowing it to sneak through the front door of the solar system unnoticed until it was far too late to do anything but watch. If we accept the premise that Atlas is not a random natural event but a constructed object, we must ask the most uncomfortable question of all: what is it doing? The most logical answer before any weapon is fired or any message is sent is that it is watching. Consider the nature of an eye. An eye does not destroy, it absorbs. It takes in photons and data. If Atlas is indeed a sensor, then for the first time in history, humanity is not the observer of the universe, but the observed. We are used to looking up at the stars and wondering what they are. It is a deeply unsettling shift in perspective to realize that the stars might be looking down and knowing exactly what we are. To understand the scope of this surveillance, we have to look at our own planet from the outside. We tend to think of Earth as a private home protected by the vast empty oceans of space. We believe that our secrets are safe because the distances between stars are so incredibly large. However, to a civilization capable of building a megastructure like Atlas, distance is likely just a variable in an equation, not a barrier. For the last 100 years, humanity has been screaming into the void. We have been incredibly noisy neighbours. It began with the invention of radio. Every time a radio tower broadcasts a song, a news report, or a political speech, that signal does not just travel to the jagged antenna on your neighbour's roof. It travels outward, up through the clouds, through the ionosphere, and out into deep space. These waves travel at the speed of light. They do not stop. They expand in a giant sphere growing larger every second. This is often called the radiosphere. It is a bubble of human noise expanding into the galaxy. If the creators of Atlas possess sensitive receivers, and they almost certainly do, they are not just seeing a blue dot. They are listening to us. They have heard the speeches of our dictators and the lyrics of our pop stars. They have detected the pulses of our early radar systems from World War II sweeping the skies for the enemy bombers. They have tracked the encrypted bursts of data from our satellites. There is a chilling thought regarding this radio leakage. We have no control over it. We cannot take it back. If Atlas is located, say, 50 light years away, they are currently watching the television broadcasts from the 1970s. They are watching us at the height of the Cold War, seeing us point nuclear weapons at each other. They are watching our history unfold in real time, judging us by the actions of our past. We are providing them with a complete unedited biography of the human race, and we did not even know we were submitting it for review. But radio waves are only the beginning. A civilization advanced enough to manipulate stars would not rely solely on listening to our noisy leaks. They would possess optical technology that defies our comprehension. When we humans look at an exoplanet, a planet orbiting another star, we see a tiny dim pixel. We can barely measure its weight or temperature. But imagine a telescope the size of a moon. Imagine a lens array spread out over thousands of kilometers. This is the kind of engineering implied by the existence of Atlas. With such a device, resolution takes on a terrifying new meaning. They would not just see Earth as a blue marble. They could theoretically resolve the night side of our planet. They would see the artificial constellations of our cities, the glowing webs of London, Tokyo, New York, and Shanghai. They would see the spiderweb networks of our highways. The presence of artificial light on the night side of a planet is an unambiguous signature of intelligence. It screams, "We are here, and we have conquered the darkness." Furthermore, they would be able to analyze our atmosphere with absolute precision. By reading the spectrum of light passing through our air, they would know the exact chemical composition of our breath. They would see the oxygen produced by our forests and the plankton in our oceans. They would detect the carbon dioxide and methane pumped out by our industries. They would see the chlorofluorocarbons chemicals that do not exist in nature, proving that we are an industrial society. They know what we breathe. They know what we burn. They know how we are slowly heating our own home. There is a deeper, more visceral layer to this surveillance hypothesis. It is the concept of the glass house. Throughout human history, privacy has been a fundamental comfort. When you're inside your home with the curtains drawn, you feel safe. You act differently than you do in public. You are your true self. Nations are the same. They keep secrets, they develop technologies in hidden bunkers, and they conduct diplomacy behind closed doors. But if Atlas is a sufficiently advanced eye, the roof of our house has been ripped off. There is a concept in physics called the diffraction limit, which limits how much detail a telescope can see. However advanced physics might use gravitational lensing using the gravity of a star to bend light to create a telescope of infinite power. If Atlas is utilizing the sun or another massive object as a lens, they could potentially map the surface of Earth to the meter. They could track the heat signatures of our nuclear submarines moving deep under the ocean. They could map the heat blooms of our hidden server farms. They could watch the migration of our aircraft like ants marching across a picnic blanket. This realization strips away the dignity of our species. It turns us into a petri dish. We are the bacteria under the microscope, busily fighting our wars and building our monuments, completely unaware that a giant eye is hovering over the eyepiece. The philosophical implication is perhaps the heaviest burden. It creates a kind of cosmic paranoia. If we are being watched, and we have been watched for decades or centuries, then our solitude is a lie. We have often asked, are we alone? We asked this with a sense of hope, looking for friends. We never really considered the predatory version of that question. We are not alone, but we are also not in a conversation. We are being studied. Think about how humans study animals. When we want to learn about wolves, we tag them. We track them from satellites. We hide cameras in the trees. We do not ask the wolf for permission. We do not explain our intentions to the pack. We simply take the data we need. To the wolf, the forest is just the forest. They do not know that their migration patterns are being plotted on a computer screen in a university halfway across the world. In this scenario, we are the wolves. Atlas is the hidden camera in the trees. This changes the meaning of every major event in human history. Our wars were not just tragic conflicts. They were data points for an external analyst. Our greatest artistic achievements were not just for us, they were cultural artifacts being catalogued by an alien librarian. Our technological breakthroughs were likely noted, categorized, and perhaps even laughed at for their primitiveness. The silence of Atlas becomes the most terrifying part of the surveillance. If they were going to destroy us, they likely could have done it already. The fact that they are just watching implies a purpose we cannot understand. Are they waiting for us to reach a certain level of technology? Are they waiting for us to destroy ourselves? Or are we simply a reality television show for a bored, immortal civilization? There is a specific type of horror in realizing you are visible when you thought you were hidden. It is the feeling of walking through a dark forest and hearing a twig snap, realizing that something has been pacing you for miles. For the entirety of human existence, we have acted as if we were the masters of our domain. We believed we were the apex predators. The surveillance hypothesis suggests that we are merely the local wildlife in a protected nature reserve, or perhaps inmates in a cosmic panopticon, where the guards can see us, but we can never see them. We are naked in the dark, illuminated by the radio waves and the city lights we so proudly created, while the cold, unblinking eye of Atlas records everything. When we look at the history of aviation from the very first Wright brothers plane to the most modern fighter jets like the F-35, there is one thing they all have in common. They are loud, they are hot, and they are visibly working very hard to stay in the air. If you look at a jet, you see giant air intakes sucking in oxygen. You see wings designed to glide on the wind. And most importantly, you see the exhaust. You see fire and smoke shooting out the back. This is how human technology works. We operate on a principle known as Newton's third law: for every action there is an equal and opposite reaction. To go forward, we have to throw something backward. We burn fuel, create an explosion, and push gas out of a pipe to push ourselves forward. But when military pilots encounter these unidentified anomalous phenomena, or UAPs, they report something that makes no sense to a chaotic, fuel-burning human mind. They report objects like the famous tic-tac. These objects have no wings, they have no rotors like a helicopter, they have no visible engine intakes, and most baffling of all, they have no exhaust. Infrared cameras which see heat often show these objects as being cold. They are not burning fuel, they are flying at speeds that we calculate to be thousands of miles per hour, yet they leave no heat trail and create no sonic boom. A sonic boom is the thunder-like noise an object makes when it breaks the sound barrier. These objects move silently. This brings us to the invisible technology. To understand this, we must look at a famous concept called Arthur C. Clarke's law. The writer and futurist Arthur C. Clarke once said, "Any sufficiently advanced technology is indistinguishable from magic." Imagine for a moment that you could time travel back to the year 1700. Imagine you walk up to a person from that time and you pull out a smartphone. You tap the glass screen and suddenly a video plays. You talk to the device and it answers you. You turn on the flashlight function and a bright beam appears without fire or oil. To that person from the past, you are a wizard. They would think you are using magic. They cannot see the microchips, the battery chemistry, or the invisible radio waves connecting you to the internet. They do not have the vocabulary to understand electronics. To them, it is just magic. Now apply that same logic to us today. When we look at a UAP that moves without engines, we are like the person from the past looking at the smartphone. We are seeing magic, but in reality, we are just seeing a level of physics that we have not discovered yet. So what could this invisible technology be? Scientists have a few theories that sound like science fiction, but are actually based on real potential. The first concept is superconductors. In our current world, when we send electricity through a wire, we lose some of that energy to heat. This is called resistance. It is why your laptop gets hot when you use it for a long time. However, a superconductor is a material that has zero resistance. Electricity can flow through it forever without losing energy and without creating heat. Right now, humans can only create superconductors at extremely cold temperatures, but if a civilization could create a superconductor at room temperature, they could create magnetic fields powerful enough to lift a ship off the ground effortlessly. This would explain why these craft are cold on infrared cameras. They aren't burning fuel, they are flowing energy perfectly. The second concept is gravity manipulation. Humans fly by fighting gravity. We use lift and thrust to push against the air. But what if you didn't have to fight gravity? What if you could control it? General relativity, the theory proposed by Albert Einstein, tells us that gravity is just the bending of space and time. Massive objects like the Earth bend space, pulling us down. Some physicists believe that if you have enough energy, you can create your own gravity field. Imagine a craft that creates a bubble around itself. In front of the craft, it shrinks space. Behind the craft, it expands space. The ship isn't actually moving through the air, it is falling forward into the space it just created. Because the ship is inside a bubble, it doesn't feel the wind, it doesn't feel the G-force. This would explain how these objects can make 90-degree turns at high speeds. If a human pilot made a sharp turn at 3,000 miles per hour, the G-force would crush them instantly. Their internal organs would be destroyed. But if the craft is controlling gravity, the pilot inside feels nothing. They are floating in a bubble of calm space while the universe moves around them. The third possibility involves dark energy or zero-point energy. We know that the universe is expanding. There is a mysterious force pushing the galaxies apart which scientists call dark energy. We also know from quantum mechanics that empty space is not actually empty. It is seething with energy at a microscopic level. If a technology could tap into this background energy of the universe, it would not need fuel tanks. It wouldn't need to stop for gas. The energy is everywhere all the time. This fits the description of UAPs that have been seen hovering for days or moving underwater without slowing down. They are not carrying fuel, they are harvesting the energy of the fabric of reality itself. We must also consider metamaterials. There have been rumours and reports suggesting that recovered fragments from crash sites contain metamaterials. These are materials engineered at the atomic level atom by atom to have properties that do not exist in nature. Imagine a metal that is lighter than plastic but stronger than steel. Imagine a skin for a spacecraft that can bend light around it, making the craft invisible to the human eye. We are currently experimenting with cloaking technology using metamaterials to hide objects from radar. It is very possible that an advanced civilization has mastered this, allowing them to become invisible whenever they choose. When we look at the sky and see nothing, when we see a silver sphere moving silently against the wind, we must remain humble. We often think that human science in the 21st century is the peak of knowledge. We think we know how the universe works, but the invisible technology of UAPs reminds us that we are still children playing on the beach while a vast ocean of knowledge lies undiscovered before us. We are looking for propellers and jet engines, while the universe might be operating on magnetism, gravity waves, and dimensions we cannot yet see. The fact that we cannot see the engine does not mean there isn't one. It just means the engine is built upon laws of physics that we are only just beginning to dream about. For decades, humanity has looked up at the stars and asked, are we alone? We wrote books about it, we made blockbuster movies about it, and we dreamed of the day the answer would be no. We assumed that when the moment finally arrived, we would be ready. We imagined a unified response where the smartest people in the room would calmly press a button, open a direct line of communication, and welcome our visitors with a message of peace. But when the presence of Atlas became undeniable, the terrifying truth was revealed instantly: we were not ready at all. The most shocking realization for the scientists and leaders involved was that there is no actual binding rulebook for this scenario. There is no global law that dictates exactly what to do when an alien intelligence arrives. For years, groups like the Search for Extraterrestrial Intelligence, known as SETI, have drafted what they call post-detection protocols. These are documents written by brilliant minds, outlining a logical path, confirm the signal, tell the world, and do not reply until all of humanity agrees on the message. But these protocols have a fatal flaw. They are non-binding. They are just polite suggestions. In the cold, hard reality of a crisis, polite suggestions are the first things to be ignored. When the data from Atlas was confirmed, the immediate reaction within agencies like NASA and the European Space Agency was not unity, but a paralysed confusion. The scientists wanted to share the data immediately, believing that scientific truth belongs to everyone. They wanted to point every telescope on Earth toward the anomaly to gather as much information as possible. However, the government officials and military advisors in the room had a completely different instinct. Their training told them to treat unknown objects not as discoveries but as potential threats. Almost immediately, the firewalls went up. Information that should have been shared globally was locked down. The fear was simple: if this entity is a threat, we cannot let our rivals on Earth know what we know. If this entity has advanced technology, we want to be the first to possess it. The dream of a united Earth vanished in seconds, replaced by the old familiar game of national secrecy. The United Nations, the organization built to handle global diplomacy, found itself hopelessly outpaced. The structure of the UN is designed for debate, for careful negotiation, and for slow, deliberate voting. It takes months to agree on a trade deal or a climate treaty. But Atlas was not a trade deal. It was an immediate existential reality. As the Security Council met in emergency sessions, the limitations became painfully clear. How do you vote on a creature that defies physics, who has the right to speak for the human race? This question, who speaks for Earth, became the source of dangerous tension. The President of the United States might feel they have the authority given their military power, but the leaders of China, Russia, and the European Union would never accept that. If Atlas is hovering in orbit, it does not belong to any nation's airspace. It is in the commons of humanity. Yet without a pre-existing agreement, every nation began to act in its own self-interest. Military forces were put on high alert, nuclear silos were checked, and submarines were deployed. Instead of presenting a peaceful, unified face to the visitor, we pointed our most dangerous weapons at each other, out of fear that the other humans would try to make a deal with the alien first. The chaos was not limited to government rooms. It spilled out into the streets and the markets. Our entire economic system is built on the idea of predicting the future. We buy and sell based on what we think will happen next year. But the arrival of Atlas made the future impossible to predict. The stock markets did not just dip, They froze. Insurance companies, banks, and logistics networks simply stopped functioning because the variable of alien contact creates a risk that cannot be calculated. The fragility of our modern life was exposed. We realized how much our stability depends on things staying exactly the same as they were yesterday. If Atlas were to attack, the response would be horrific, but at least it would be simple. We would fight back. But the scenario of Atlas simply staying, hovering there silent and observing, created a different kind of panic. It is the panic of the unknown. This silence acts like a mirror reflecting our own insecurities back at us. Religious institutions faced a theological crisis trying to fit this new being into ancient scriptures. Do aliens have souls? Are they demons? Are they saviors? Without a clear answer, radical groups began to form, some worshipping the entity, others demanding its destruction. The institutional gap is this massive empty space between what we need to be and what we actually are. We need to be a planetary species capable of thinking as one collective mind, but we are still just a collection of tribes separated by borders, languages, and old grudges. We have built excellent institutions for managing human-to-human conflict, but we have built nothing for human-to-non-human interaction. This lack of preparation creates a dangerous vacuum. In the absence of a clear voice from the UN or the scientific community, other voices rush to fill the silence. Private billionaires with their own rockets might try to send their own messages, bypassing governments entirely. Rogue nations might try to signal Atlas independently. The noise from Earth would be a cacophony of conflicting shouting rather than a clear greeting. If Atlas continues to await, the pressure on our institutions will likely cause them to crack. Governments rely on the illusion of control. They need their citizens to believe that they can protect them and manage the situation. But against a Type 2 civilization, a society capable of harnessing the energy of an entire star, our governments are powerless. As the days turn into weeks, and Atlas remains a silent observer, the population will realize that their leaders are just as scared and clueless as they are. That realization is dangerous. It leads to civil unrest, to the breakdown of law and order, and to a primal survival instinct taking over. Ultimately, the arrival of Atlas proved that our technology has evolved much faster than our wisdom. We have the radio telescopes to hear them, and the rockets to meet them, but we do not have the political maturity to greet them. The tragedy of the institutional gap is that while we were busy watching the skies for monsters, we forgot to clean up our own house. We are meeting the universe not as a dignified, unified family, but as a squabbling, frightened group of children fighting over who gets to hold the front door key. And as Atlas watches, our greatest threat might not be the alien in the sky, but our own inability to work together on the ground. The long wait of November. As the calendar turns to November, a unique silence falls over the astronomical community. Usually this is a time when the northern hemisphere prepares for winter, turning inward, away from the cold. But this year the entire world is turning outward. The eyes of humanity are fixed not on the falling leaves or the first snow, but on the blinding glare of the sun. For weeks, Comet Atlas has been hidden behind our star. It has been passing through the solar furnace, subjected to temperatures of thousands of degrees. This is the ultimate test of survival. The question on everyone's mind is simple but terrifying. Did the heat destroy it? Did the massive gravitational pull of the sun tear it apart, leaving nothing but a cloud of dust? Or did the heart of the comet, the nucleus, survive the journey? During this period of invisibility, the world relies on our mechanical eyes in space. The James Webb Space Telescope and the Hubble Space Telescope are positioned and waiting. They are not just taking pictures, they are hunting for specific signatures. James Webb, with its abilities to see infrared light, which is essentially heat radiation, is looking for chemical changes. It is searching for water vapor, carbon dioxide, and complex organic molecules. The scientists are waiting to see if the intense heat has cooked the comet, releasing new, never-before-seen gases from deep inside its frozen core. Meanwhile, Hubble is watching for the physical shape. It is looking for the tail. If Atlas has fragmented, Hubble will see a messy cloud. If it has survived, Hubble will see a sharp, bright definition returning from the darkness. The return in December. Then, as December arrives, the answer comes. It does not come as a whisper, but as a shout across the heavens. Atlas re-emerges. It survived. Not only did it survive, but the heat of the sun has transformed it into something far more magnificent than before. Having shed its outer layers, the comet is now releasing massive amounts of gas and dust reflecting sunlight, with an intensity that rivals the full moon. It is visible even during the twilight hours. The tail of the comet has grown immensely long, stretching across a significant portion of the night skies. It looks like a great celestial bridge connecting the horizon to the stars. In the cold, crisp air of December, people stand in their backyards wrapped in heavy coats, breathing out clouds of steam, watching the great traveller return. It feels like a holiday miracle, a cosmic lantern lit just for Earth, a twist of gravity. However, as the weeks pass, astronomers begin to notice something strange in the data. The trajectory of the comet is not matching the mathematical models. According to the original calculations, Atlas was supposed to swing around the Sun and then be flung back out into the deep darkness of space, not to return for another 80,000 years. But space is a dynamic and chaotic place. As the comet passed near the Sun, it experienced a phenomenon known as outgassing that was far more powerful than predicted. Jets of gas erupted from its surface, acting like rocket thrusters, slightly altering its speed and direction. Simultaneously, the gravitational pull of the major planets, particularly Jupiter, tugged at it in just the right way. By late December, the announcement is made shocking. The scientific world comet Atlas is not leaving. The combination of forces has captured the comet. It has slowed down just enough to enter a wide, stable and elliptical orbit around the Sun that keeps it relatively close to Earth. It will not crash into us, it is safely millions of kilometers away, but it will not disappear into the void. It has become a permanent member of our inner solar system. The new neighbour. This changes everything. Suddenly Atlas is no longer a passing visitor, it is a neighbour. It becomes a second moon of sorts, though much farther away and behaving differently. This shift creates a permanent change in our night sky. While it won't always be as bright as it was in December, it will remain a visible object to the naked eye for years, and visible with simple binoculars forever. It becomes a constant companion to the Moon and Venus. The psychological impact on humanity is profound. For the entirety of human history, comets were seen as omens of doom because they were unpredictable and fleeting. They came, terrified us, and left. But Atlas is different. It stayed. It represents resilience. It faced the fire of the sun and refused to be destroyed or banished. A civilization transformed, the permanent presence of Atlas ushers in a new golden age of exploration and unity. 1. The science of accessibility. Because Atlas is now a permanent resident, we do not have to rush to study it. We don't need to launch a desperate high-speed mission to catch it before it flies away. We can take our time. It becomes a floating laboratory. Within a decade, humanity launches regular missions to the comet. We land probes on its surface not just to take pictures, but to set up long-term research stations. We study the ancient ice that holds the secrets of the birth of the solar system. We learn how to mine its resources, water, and rare minerals, testing technologies that will one day allow us to live on Mars or the moons of Jupiter. 2. The cultural shift culturally. The Star of December becomes a symbol of global unity. Because it is in a wide orbit, it is visible from both the northern and southern hemispheres. It does not belong to one nation. It hovers over everyone equally. Art, literature, and music experience a renaissance inspired by the comet. New festivals are created to mark the points when Atlas is closest to Earth each year. It replaces the old fears of the dark forest of space with a sense of wonder. We realize that the universe is not just a cold, empty void, but a place that can gift us with beauty and resources. 3. The overview effect on the ground. Astronauts often talk about the overview effect, the cognitive shift that happens when seeing Earth from space, realizing how fragile and connected we are. With Atlas permanently in the sky, humanity experiences a ground-based overview effect. When we look up, we see a dynamic, changing world that we are connected to. It forces us to think bigger than our daily problems. It reminds us that we are crewmates on a spaceship called Earth sailing alongside our new companion. A future of hope. By the end of the year, the fear that started the saga has vanished completely. It has been replaced by gratitude. The re-emergence of Atlas is not just an astronomical event. It is a catalyst for the maturation of our species. We stop looking down at our phones and start looking up at the stars. We realize that we are capable of understanding the cosmos, and that the cosmos, in its own gravity-driven way, has decided to keep us company. The year ends not with darkness, but with a sky that is twice as bright, lighting the way for a future where humanity finally reaches out to touch the stars, no longer afraid of the dark. As the great celestial traveller known as Atlas begins its long journey back into the deep, dark silence of the outer solar system, we find ourselves standing at the end of a chapter. The bright streak that painted our skies is fading, turning from a brilliant spectacle into a faint memory, and finally into a ghost of light that only the most powerful lenses can see. But as the object itself retreats into the void, it leaves something behind. It leaves us changed. It leaves us with a silence that is not empty but full of understanding. Tonight we do not need to worry about the numbers or the speed. We do not need to calculate the trajectory or measure the degrees of separation. Tonight we simply rest in the aftermath of the encounter. Think for a moment about what it means to be here right now, lying in the comfort of your bed while something so massive and so ancient drifts silently through the vacuum above. Throughout this journey we have asked many questions. What is it made of? Where did it come from? Is it a comet, an asteroid, or a messenger? But as your breathing slows down and your eyes grow heavy, the answers to those questions matter less than the feeling they inspired. The true gift of Atlas was not the data it provided to our scientists. The true gift was the way it made us lift our heads. For a brief moment in history, millions of eyes looked up at the same patch of sky. We stepped out of our houses, away from the glow of our screens and into the cool night air. In that shared gaze, the borders that separate us on the ground seem to dissolve. When you look at the infinite canvas of the universe, the lines on a map disappear. Let that feeling wash over you now like a gentle wave. Imagine the Earth as it truly is, a small, beautiful blue marble suspended in a sunbeam. From the perspective of Atlas moving millions of miles away, our planet is just a point of pale light. This is not a thought to make you feel lonely. It is a thought to make you feel light. It is a thought to make you feel unburdened. If we are so small, then our worries are small too. The stress of the day, the lists of things to do, the anxieties that tighten our chests, they are microscopic against the backdrop of the galaxy. Let them go. Let them float away like dust motes caught in a beam of light. You are free from them now. Breathe in deeply, filling your lungs with the air of this planet, and breathe out, releasing the tension into the night. Consider the vastness of the space that surrounds us. It is a blanket of velvet, dark and soft. It is not a scary emptiness. It is a peaceful stillness. In that silence there is a rhythm. The universe is dancing a slow, eternal waltz. Planets spin, moons orbit, stars burn with a steady ancient fire, and you are part of this dance. You do not have to do anything to be part of it. You do not have to try. Gravity, that invisible embrace of the earth, holds you safely. It anchors you to your bed, to your room, to the ground, keeping you secure as the world spins. You are moving at 1,000 miles per hour as the earth rotates, yet you feel nothing but perfect stillness. You are traveling 67,000 miles per hour around the sun, yet you are completely at rest. The universe carries you. You only need to trust it. As you drift deeper towards sleep, remember that the atoms in your body are the same as the atoms in the comet. The carbon, the nitrogen, the oxygen, they were all forged in the hearts of dying stars billions of years ago. You are not just in the universe, you are of the universe. You are stardust that has come together to breathe to think and tonight to sleep. Atlas was like a distant cousin, passing by a window, waving hello before continuing a long voyage. It reminded us that we are residents of a very large, very mysterious neighborhood. And now the curtains are closing. The show is over. The sky remains watching over you as it has watched over every human being who has ever lived. Think of the ancestors who looked up at the same stars. They saw the same moon. They felt the same night wind. They too sought comfort in the dark. And just like them, you can find rest here. There is a timeless comfort in knowing that the stars will be there tomorrow night, and the night after that, and for eons to come. You do not need to hold the sky up. It holds itself. Your eyelids are becoming heavy, so very heavy. The visual of the comet is fading now, becoming just a gentle streak of silver behind your closed eyes. The tail of the comet is like a stream of sand pouring slowly, counting down the moments until you are fully asleep. 1 grain of sand, 2, 3. The distance between you and the stars is not a separation, it is a connection. The light from those stars has travelled for thousands of years just to reach your eyes, just to kiss the atmosphere of our little home. It is a lullaby of light sung across the void. Everything is slow now. The orbit is wide and lazy. There is no rush in the cosmos. Galaxies take hundreds of millions of years to turn. Stars take billions of years to burn out. In the face of such time, there is no urgency. There is only the present moment. This soft, warm, quiet moment. You are safe in the harbour of the night. The vessel of your body is at anchor. The tides of sleep are rising, lifting you gently, rocking you back and forth. Whatever Atlas was, it has done its job. It has opened our eyes to the wonder, and now it allows us to close them in peace. We are the dreamers of the universe. We are the way the cosmos knows itself. and even the universe needs to rest. So let the darkness wrap around you like a warm quilt. Let the silence fill your ears like a soft hum. The comet has gone into the dark and you can follow it into your dreams, drifting, floating, weightless. You are small, but you are precious. You are a child of the stars resting in the cradle of the earth. Good night, traveller. Good night to the stars. Good night to the comet, and good night to you.